Hi, this is Dr. Matecki. In this video, we're going to talk about the Grossman model a little bit. And what I'd like to do is try to make it as simple as possible and just focus on the four main graphs that we see in the Grossman model. So the Grossman model attempts to explain human behavior, how we behave on a daily basis when health is an important factor. And so all of us try to make ourselves as happy as possible by choosing what to buy, how to spend our time, and this model is no different. It's just that there's a focus on health. So when health is important, how do we make choices on a daily basis? So one of the most important variables in this model is H, right here. So that measures how much health capital you have. In other words, you can think of this as a sort of measure of how healthy you are. So how do you get H? Well, you get H by spending time getting healthy. So this could be like exercising, informing yourself about dietary habits, something like that. So time spent getting healthy is represented by the variable TH. The other way you can get healthy is by buying things that make you healthy, like medicine. So M is medicine. But the only thing is, health has can be thought of in a couple different ways. One way you can think of health is as a capital good. So capital good being like a machine or a tool. So the salient feature of health capital in this regard is the fact that it lasts for many periods, but it does wear out, right? Just like a machine wears out, your health wears out if you don't maintain it. If you don't exercise and you sit on the couch, then you're going to become less healthy. So what the model assumes is that each period a fraction delta goes away, gamma. So what that means is how much health we have in any given period. So HT tells us how much health capital we have in period T. You can think about T as just today. So the health capital we have today, and this whole thing on this side means that how much health we have today is a function of three different things. It's a function of how healthy we were yesterday, health capital at period T minus 1, how much time we're spending today making ourselves healthy, and how much medicine we're buying today. Right, so notice that we don't get to maintain all of our health from the previous period. So the health that we had yesterday, we only get to keep 1 minus gamma of this health capital. Okay, with those preliminaries out of the way, let's talk about the first graph. The graph that I want to go through first is the one showing health as an investment good. We can also think of this as the MEC graph. Okay, so on the x-axis, what we're going to do is measure the quantity of health capital that we have, H. Okay, so the further we move to the right along the x-axis, the more health capital we have. And one of the interesting things in this model is that there's something called H min, which means that if we don't maintain at least some minimal amount of health, we're not going to be able to do anything. We're either going to die or be bedridden, right? So in order to have any sort of productive time to do anything else, we need to maintain at least some minimum level of health, okay? On the y-axis, we are measuring the rate of return. Just like we might be concerned with the rate of return on a factory or a machine, we can talk about health capital producing a rate of return. All right, so I'm going to plot what we call the MEC curve. MEC stands for the marginal efficiency of capital. And notice that this line is downward sloping. So what that means is that as H gets larger, the rate of return that we get from each subsequent unit of health capital is diminishing. Okay? So imagine when we have just a little bit of health, say we're at H min. So let's say that we're down here at H min, right? We would follow the graph up and we could see that the marginal efficiency of capital at this point is very high. There's a high rate of return when our health capital is low. So imagine if we are very unhealthy, just a little bit of exercise or a little bit of improvement in our diet or going to the doctor is going to yield very large benefits. For example, let's suppose we're at a level of H. Let's call it H low. what this graph tells us is that if we go up to the MEC curve from this H low position, and then go over to the y-axis, we can see that we are earning a high rate of return on our health capital. However, let's say we make ourselves really healthy and then we end up with a high level of health capital. Let's call it H high. The MEC curve is downward sloping, which means that the return on subsequent units of health capital are low. So when we are already very healthy, more investment in health capital is going to give us a low return. When we're very unhealthy, investments in health capital will yield a very high return. All right, so now the question becomes, what level of H are we going to choose? Okay, so in econ, you're going to notice that we're going to make choices by comparing costs and benefits. In particular, we're going to compare marginal costs and marginal benefits. The way to optimize is to choose the point at which marginal costs are just equal to marginal benefits. Okay, so in this sort of setup, the marginal benefit is given by this MEC curve. So really what we can think of this curve as a marginal benefit curve. In particular, the marginal benefit of investing in health capital. So now the question becomes, well, how can we compare this marginal benefit to the marginal cost, right? Well, we can think of investing in H as having two costs, right? So if we put time and energy into producing H, there's an opportunity cost. What else could we do with that time and money that we're putting into health? All right, so I've reset the graph here just a little bit. Now the nice thing is we can measure the cost of capital, the marginal cost, the cost of acquiring one more unit of health capital. We can think of that as the marginal cost of H. Again, is a function of two things. We're going to call R the rate of return that you could earn on other uses of the resources you're putting into health capital. Okay, so this is a measure of the opportunity cost, R. And so you can think of all these things as being sort of measured in percentage terms. So that's why we can measure both the benefit, the rate of return that we get from health capital on the y-axis, and we can measure the cost. Think of them all as percentages. So the opportunity cost is R, and then a fraction wears out each period. So the marginal cost, the cost of acquiring one more unit of health capital, is always going to be R plus delta. So now the question becomes, how much health capital are you going to want to produce? So let's suppose that our costs are equal to R1 and delta 1, measured on the y-axis right here. So what the basic theory of optimization says is that we are going to want to choose H so that the marginal costs and marginal benefits are just equal. So in other words, we're going to go over to the MEC curve from the y-axis till we hit the MEC curve and drop down and to see which value of H is associated with that. We're going to call this H star to let us know that it is an optimal amount. All right, so now why is this an optimal amount? Okay, so let's think about what if H were something less than H star? What if we were down here at something like H1? If we were at H1, we could go up to the MEC curve and see that the marginal benefit of investing in health is very high, much higher than the cost, and we could get additional benefits by increasing H. If we were at something higher than H, let's say H2, we would go up to the MEC curve and see that the marginal benefit is lower than the costs, right? The benefits do not justify the costs given by R1 plus delta 1, so we've invested in too much capital. So there's a perfect amount, not too high, not too low, and that turns out to be H star, where the costs are just equal to the benefits. It's also useful to see, what happens when R or delta changes. So now let's call this H star 1 to differentiate between what I'm going to do here in a second. So now let's suppose that depreciation is different from gamma 1. Let's say it turns out to be gamma 2, which is lower than gamma 1. So let's say that we have R1 plus gamma 2. Now, one reason why depreciation might be lower is because someone is younger, right? So in this model, when you're young, you have a low rate of depreciation, and when you're old, your health tends to deteriorate faster, and so the way we model that is by having a higher rate of depreciation. So R1 plus gamma 2, if gamma is lower, the cost of acquiring health capital is lower, and so we can see that this lower cost of capital is going to intersect the MEC curve down and to the right from where we were previously. So we're moving down to the right along this curve, and we can see that the optimal amount of health capital is now higher since our cost is lower. So we can call this marginal cost 1. We can call this MC, for short for marginal cost, MC2 is equal to R1 plus gamma 2. Okay, so we could interpret this as showing that when we're younger, with the lower depreciation gamma 2, we are going to choose a higher level of H star, right? We're going to choose a higher level of health capital. We're going to be healthier when we're younger and not quite as healthy when we are older. Okay, so I've reset the graph again as I want to show you one last thing. So suppose that something happens to us that makes us a more efficient producer of health. One common thing that can create the situation is if we become more educated. The more educated we are, the better we can use the tools around us, the better we can use our time effectively to make ourselves healthy. So the way that we would show an increase in efficiency is by shifting the MEC curve to the right. So if we have more education, we can illustrate this by drawing a new MEC curve off to the right of the old one. So let's call the old one MEC1. Let's call the new one MEC2. And so what it means when we shift this curve to the right is that for any given cost of capital, right, we are now going to find it optimal to produce a larger amount of health capital. Okay, so for the same depreciation and opportunity cost with more efficient production, MEC curve 2, we are going to produce a higher level of H star, H2 star. The second graph I want to show you can be thought of as a sort of production function. Right? So in this model, in order to have productive time available to us, we need to be healthy. Okay? So the key concepts that we're going to show here is that the more H you have, the more time available for other activities you're going to have. Right? And so the other time is going to be spent either working, TW, playing, which we call TZ, or making more H, which is called TH again. Another key feature of this graph is going to be diminishing returns. So we're going to show that as we produce more and more H, the additional productive time we're going to get is going to be decreasing. Okay, so on this graph we're going to measure the amount of health capital we have, H, on the x-axis, and on y we are going to measure how much productive time we have available to us. So now, again, if we don't have a certain minimal amount of health, H min, we are going to get exactly 0 productive time. So that's going to be sort of our starting point here. The relationship between H and TP is going to be upward sloping, but to illustrate diminishing returns, this graph is going to have to flatten out at the top. So the graph is going to end up looking something like this: upward sloping, steep at the beginning, but eventually it's going to start flattening out at the top, which indicates subsequent investments in health capital are going to yield less and less additional productive time. right? So what this graph shows us is that at a level of health capital, let's call it H star 1 from our previous graph, we start there, go up to the curve, over to the y-axis. So H star 1 is going to give us some value of productive time, let's call it TP1. So remember when we had higher education, we chose a level of health capital that was a little bit bigger. We called it H star 2. So as you'd expect, with more health capital, we are going to have more time available to do all the things we want to do. So now where does this time, extra time, come from? Well, it's because we are going to spend less time being sick. So in this model, there's also something called TS, right? And this is your sick time. So this is just time that's spent doing nothing or lying in bed, right? It's not productive time. Okay, so the reason we have more productive time here with higher H star is because we have less time being sick, less time being lazy, doing nothing. So an increase in H caused us to move up and to the right along this curve from a point like A to a point like B. The third graph that I want to show you briefly is the graph of the labor-leisure trade-off in this model. So we've just talked about how we go about choosing how much health we're going to produce, health capital we're going to produce, and then once we've chosen H, we can figure out how much productive time we have available to us based on graph number 2. So after we've used up some time to produce health, we have all this other time left over that we have to choose to allocate somehow. So the other options we have remaining are to spend time working and spend time playing. So the time working we call TW, the time playing, the time in leisure, recreation, having fun, we call TZ. All right, so now there's a fundamental trade-off here. So if we spend more time working, that means we have less time for leisure and vice versa. So the relationship between TW and TZ, so let's say that when we were in possession of health capital H star 1 from the previous graphs, we can draw a downward slope and relationship between TW and TZ that looks like this. So now we're going to say this assumes we have H 1 star health capital. Okay, so remember the productive time associated with H1 was TP1. Okay, so if we were to put all of our productive time into working, then we would end up with this y-intercept point right here as the amount of time we would spend working. That represents the maximum time working. That's all of our productive time. Likewise, if we put all of our time into producing leisure, we would end up down at this point here, the x-intercept. So this is also equal to TP1 as in. So what this implies is that the consumer can choose any combination of TW and TZ that is on this line or inside the line. That's we could think of that as sort of a feasible region. Those are feasible combinations of time spent working and time spent playing. Now, of course, where the person is actually going to choose to allocate their time depends on their wants and needs, and these things are expressed by the utility function. But that's something I don't want to worry about too much. I'd rather you just focus on the trade-off present in this graph. All right, so what does it mean if we were to choose a level of H star that is either higher or lower than H1 star? So remember, when we got more education, we chose a level of H star that was higher than H1. We called it H2. So what that meant is that we have more total productive time available to us because we're healthier, spending less time being sick. So with higher H star, we would have a trade-off that is shifted out to the right. Okay, so now this one here is going to represent the budget, the available time when we had H star 2. Okay, so again, the maximum time spent working would be all of our productive time, which was TP2 in the previous graph. The maximum time playing, the x-intercept, would be the exact same amount of time. So this would be, if we put all of our time into playing, we would be able to spend TP 2 hours plane. One final thing I want to point out with this graph here is that it's logical to think that if we spend more time producing health, we're going to have more health, and that's going to give us more productive time. But remember, at some point, we're not going to get very much additional benefit from spending more time producing health. So it is possible to have two different outcomes here. So the one that makes the most sense is this one here. So we spend more time producing health, so we have more of our time is spent in producing health. We get more H, which gives us more productive time. However, it is possible that we could spend so much time producing health and not get a very large benefit from it, so that we actually have less time left over for everything else. Okay, this model allows for both of these outcomes to happen, so there's a little bit of ambiguity here. I should have also mentioned before that TW, the reason that we want to spend time working is so that we can get money, right? So what can we do with the money we earn from working? Well, we can either buy medicine to make us healthier, or we can buy things that make us happy, things that would be considered entertainment, leisure, that sort of thing. We can buy a ticket to a baseball game, or we can buy a video game, whatever the case may be, but that's why we're going to choose to work. Right, and the final trade-off, the final graph in this Grossman model is going to be the production possibilities frontier graph. You likely remember seeing a PPF in Eco 201, Principles of Microeconomics, and it looked something like this here. So the PPF in 201 was used to show the concept of a trade-off, right? So if we were going to produce two things, let's say guns and butter, right? This graph would be downward sloping, look something like this, to illustrate the fact that as we produce more and more butter, we have to give something up to get that. What we give up is guns. So the production possibilities frontier in the Grossman model, however, we're going to show over here, is quite different, because there isn't always a trade-off between the two things that we want to produce. So in this setup, we're going to produce two goods. We're going to produce H, so we're going to put that on our x-axis again, so we're going to produce health capital, and we're going to produce something that Michael Grossman called Z, which is home good, another way of saying these are things that give us enjoyment, sort of like the leisure, fun things, okay? So we can produce H or Z. So now remember, there's got to be some minimal amount of health capital. We'll call this H min, or we're not going to be able to produce anything else. So we have a starting point here of on the y-axis at H min. Okay, so initially what happens when we produce more health is that we have more productive time available to us, and we can spend some of that time working, making money. We can also spend some of that time producing Z in leisure. Okay, so the more health we have, the more of all these other things we can get. So there's an upward sloping relationship between H and Z initially. Looks something like this. Because there are diminishing returns to producing H, though, the curve starts to flatten out at the top. So, and then it actually gets to the point where we could spend so much time producing H with so few benefits to doing so that we're going to have less time left over for producing the home good Z. So we can talk about producing even more H, but that's going to require a trade-off, right? So we produce more H until the point where that's all we're doing is producing H. Yes, we're maximizing H, but we get zero home good. So we're back down to the y-axis, or to the x-axis here. So we can refer to this as H max here. So that is the maximum possible health we can produce. The peak of this curve here, we could think of as the maximum home good we can produce. We could call this Z max. Okay, so remember, we get happiness out of both consuming the home good Z, but we also get utility. We get happiness from H itself, remember? So H is both a capital good and a consumer good. So we like H just because it makes us feel good, it makes us happy. Okay? So it's logical for the consumer to choose anything between H max and Z max. If the person only cares about consuming the home good, they're going to want to choose to maximize Z, and we'll end up producing H that's associated with this point on the curve. If the person cares more about H as a consumer good, then we're probably going to be somewhere over in this area here, right? So we're not maximizing Z because we also want some H to make us feel good. Now, it's also possible if someone cares only about health, then they're just going to maximize their health capital, not produce any home good Z, and we'll be down here at the x-intercept.